Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over another practice problem involving determining the K value or your equilibrium constant of a chemical equation based on what you know from the K values of other equations that are related to the equation you're looking at. That was a mouthful. What I mean is basically is that there are relationships between your equilibrium constant and chemical equations that you need to use to figure out what the new equilibrium constant of a target equation is. And so let's get into this. So for this problem, we're given this equation and we are given the equilibrium constant for this equation. But our target equation is the following. So we're given NH3 gas, and that's going to be in equilibrium with 1/2 N2 gas plus 3/2 H2 gas and we're asked to find K prime. So what is K prime? The equilibrium constant for this reaction, and we're given this reaction. So there's a few things we need to remember. So as far as relationships go between your K, your equilibrium constant, and the chemical equation, you have to remember that if you multiply your equation by a factor, then the K value for the new reaction after you multiplied by the factor is also the original K raised to that same power of the factor that you multiplied by. So if you multiply your equation by 2, then you got to raise the original K value by a power of 2 to get the new K value for that new equation you have. The other thing is, if you reverse a reaction, if you flip it around, then the new K value for that flipped equation is going to be the original K value, but taken the reciprocal of, right? So 1 over the original K value. So let's get into this. So here, first thing you'll notice is I have ammonia on this side, but here I have ammonia as a reactant. Here it's a product, here it's a reactant. Here I have nitrogen and hydrogen as reactants, here I have them as products. So this equation is the flipped version of this equation. So that means that the first thing I should do is take this equation, take this equilibrium constant and take the reciprocal of it. So at the very least, because it's flipped, then that means that the new K value, K prime, right? Oops. Sorry about that. So here, K prime is at least equal to 1 over the original K of this reaction, the K of this reaction. So it's going to be 1 over K for this one. But we're not done yet, because the other thing we notice is that here we have, for your nitrogen, you have 1. And for your hydrogen, you have a coefficient of 3. But here we have 1/2 and 3/2. So both of these have been divided by 2. These have been divided, these have been divided by 2. And this one has also been divided by 2, because 2 divided by 2 is 1, and that's what we have here, a 1. So that means that to get from this equation to this equation, I have to multiply this equation by 1/2. So if I multiply this equation by 1/2 to get this one, then I have to raise the k expression also to 1/2. So that means that this whole thing here is raised to the power of 1/2. And that means that this is also equal, the power of 1/2 is the same as taking the square root. So that means that I am taking the square root of 1 over k. So now all I have to do is plug in my k. And so that means that I'm going to have to take the square root of 1 over 5.6 times 10 to the 5th. And when I do that, what did I get for an answer? It's going to be 1.3 times 10 to the negative third. And that, ladies and gentlemen, is how it's done. So I hope you enjoyed this video. If you liked the video, if you learned anything from this video, if this was helpful in any way, then please, by all means, like the video, share the video with your friends, hit that like button. Also, make sure that you subscribe to my channel, hit that notification bell, and when you do, make sure you click all, and then as well as leaving a comment down below. So please do that, and let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me, and have a great day.